All right. So my name is Mohammed. I'm the CEO at VexHost. What we are is a public and a private. We have a public cloud based here in Montreal, and we also do private cloud deployments for customers. I've been personally involved in OpenStack since 2011. So I've seen a lot of things happen. A lot of changes have happened over the years, and over those years, we've had a lot of very interesting things come up down the line. And what I wanted to do is talk a bit today about how some of the issues that we faced, how we dealt with them. I'm not going to go into the very details, but I'm kind of going to give the general idea of how to go ahead and the approach in solving these issues. And so, awesome. Okay, so we've already kind of went through this. I'm a person that's very on IRC, so you'll find me a lot there on the OpenStack channels if you need anything. And that I had to put that slide because we had to come up with a shitty slide, but I obviously should make a disclaimer that this has never happened in production and this was all in testing. So we never have issues ever, as you can tell. So first of all, upgrades. Upgrades are the thing that we all hate to do. A lot of people are probably running old releases of OpenStack and they want to get going, but they're not really moving because they think that if they upgrade, everything's gonna break, which it will. But so the way that we do it to minimize the amount of things breaking is, first of all, you absolutely need high availability on your control plane. If you don't have that, you should, because it's really critical and it's the best way for you to be able to do upgrades successfully. Also, load balancers are going to be the only way you're going to be able to complete an upgrade without pissing off the entire world. The reason is you'll be able to kind of move load from your old version to the new version. And I'll kind of dive in a bit more into how to do that. Your automation has to happen because obviously I'm sure all of you have a cloud that you're testing your upgrades on, and then you upgrade your production cloud. I'm sure everyone does that here. Nobody does it, let's be honest. But you gotta have automation because you gotta figure out all the things that are unpredictable that are gonna come up. You wanna iron them out all before you actually do your upgrade. So the kind of little mix of how we do upgrades and how things have always worked for us. First of all, you need to make sure that your control plane, a single machine, should be able to handle all of the load of your OpenStack cloud. That's kind of the most critical first step that you need. So first of all, you start off, back up all your databases, your configs, whatever you need, because you will probably need to roll back at some point. So the first thing we do is we'll shut down a service, like for example, Keystone. We'll shut it down on, let's say if we have 3 controllers, we'll shut it down on 2 controllers and leave it running on a single controller. And we'll take out the 2 Keystone instances and take them out of the load balancer, so you only have one that's serving everything. Then you upgrade that instance that is serving everything. The idea behind that is you will do the upgrade on that one, you will upgrade the database, sync everything up, and then you start it up. If everything's working again, the only downtime you had is the downtime from where you took down the service and you started it back up, which should be a few minutes. Now, the nice thing about this is if something went wrong, all you have to do is restart your database and start up the old 2 unupgraded nodes, and you're back to everything's okay. And the nice thing is leave the upgraded node as is, because it's going to have a lot of information for you to troubleshoot what went wrong, so you can have round 2 and then eventually hopefully finish your upgrade. And so obviously you're excited, you just upgraded your cloud, so you're going to go out to celebrate, but then you're going to get a call that some cryptic feature that somebody used 6 months ago is not working anymore. So testing and monitoring is the second thing. So that's one of the things that we had a lot of experience with. So in a public cloud environment, people test their clouds and they do all sorts of stuff with it. So for most of our smoke tests, we think that everything just went by okay until we find out that something is not working anymore. Just after an upgrade, if you just create a new VM and say, hey, I create a new VM, it's pingable, everything's working great, that's an okay test, but there's lots of other cases that are probably not covered by it. So we suggest to really take advantage of Tempest. So for those that don't know, Tempest is really how OpenStack gets tested. Every single change of OpenStack gets deployed, and then Tempest is a set of API tests that run against it. So it pretty much makes sure that OpenStack is responding as is, as a complete system altogether. So if you run Tempest against your cloud, you're pretty much going to be really testing all the features, whether you use them or you don't use them. Sometimes, depending on how your cloud is deployed, there will be some failures, which is why you want to maintain a list of blacklisted checks so you know what's going to run and what doesn't run. It takes almost like 2 hours to run Tempest. So there's what we call smoke tests. You should run the smoke tests, prefer that. And then you can have, nightly runs of, the full Tempest run to see how that goes. But warning, don't run Tempest as admin on a production cloud. It will delete stuff. It will remove things. So you want to give it a set of users. There's 2 ways of deploying it. So you want to use the way where it's predefined users, or you're going to have a bad time. And then there's also a thing called Rally. So if you have so much time that you've implemented Tempest on your cloud and you're running all sorts of tests, Rally is a benchmarking tool. So if you want to make sure that one of your users can launch 200 VMs in a single moment, then you can do that with Rally. So if you want to go through that sort of punishment, be my guest, but I'm not going to do that. So once you got nice testing, your management's going to be like, hey, why don't we have live migration and all these other fancy things that everybody else has, right? And so there is live migration if you use local storage, and it's called block level migration. Personally, in my experience, it never worked, and it's just a big hassle. So we were like, hey, let's get Ceph. So what we did is, so if you have a private cloud and you can just call your users and say, hey, we're shutting down this whole thing over the weekend and we're going to restart it from scratch, you should be very thankful. But we can't do that. We got a public cloud that's running. We got workloads that are running. We literally have to do an upgrade in place. So how do you switch storage systems on a production running cloud? By doing really bad things. So OpenStack is an open source project. The code is all there. We can kind of see what's going on and understand both storage drivers. So pretty much what you do is you start up by deploying a Ceph cluster on your cloud. Once you have that Ceph cluster running, the next step is you set up a new set of compute nodes, and you configure those compute nodes to use that Ceph cluster. And you disable all your old compute nodes that are not using the Ceph cluster, because you don't want those to be doing anything, because it's probably going to end up in something bad. Then once you do that, you got to go to Glance, and unfortunately David Samar, who couldn't attend today, he has a whole blog post about converting your images by maintaining the same ID from QCOW2 to RAW, because you need RAW images to work with Ceph if you want things to work properly. So you have to convert all of those while maintaining the same image ID, because you got customers that are launching VMs using that same image ID, and you want to break their CI stuff for them. And then this is the part that gets really messy. You shut down the virtual machines for this customer. You convert the QCOW disk and you migrate it onto the Ceph cluster to the name that OpenStack expects it, and you modify the database records to point towards a compute node that's free, and then you start up the VM hoping that everything went okay. So I think it's like a 300-line script that we got at this point, but it worked, and we never have to use it ever again, and we wish that no one ever has to go through this. But at the end of the day, anything's possible, guys. If you want to have sleepless nights, anything's possible. So now you got centralized storage, but now you got a whole bunch of servers with a lot of empty slots on their drives because everything is centralized. So we're going to talk a bit about hyperconverged infrastructure. So a few years ago, Marcos, I was like, hey, we're thinking of doing hyperconverged. And he's like, that's a bad idea. You shouldn't do it. And I was like, we'll try it anyways. So that's what we did. So we figured out, like, hey, where could this go wrong? The biggest problem was, the CPU usage. You don't want your VMs and your Ceph cluster to be contenting for usage. So what we started is we run a very low amount of OSDs in every compute node. So like we're talking like 2 to 4, nothing more. We do it just for SSDs. So we don't have like a 4 terabyte OSD that like crashes, and we don't want to deal with that. So it's really quick to recover. Don't cheap out on SSDs. Like seriously, don't cheap out. If you can't afford good SSDs, just don't do it, because you will take all those SSDs and throw them in the bin, and that's very expensive. And you got to be realistic about, like, Ceph is going to use CPU usage, and the compute node is going to use CPU usage. So you got to you can't put like 24 OSDs and 400 VMs on a single machine and be like, this is my cloud. It's just not going to run. So an interesting fun problem is, so at first you'd say, hey, let's reserve this core for this OSD and this core for this OSD. So for those who are maybe going to learn more about Ceph, an OSD is really like a daemon that runs and stores all the data. So it's a data storage device, you could say that. And so at first you want to say this data storage device gets one core on the machine and this other one gets another core on the machine. So turns out computers are really dumb. What they do is when they send a write request, they wait for the disk to respond, and then the CPU is in like what we call an IO wait state. So it's just sitting there waiting for the disk to say, hey, I got it, I wrote everything. So in high load situations, now your Ceph is really literally stuck on this one core because it cannot move to any other cores. Normally, the kernel would move it and make it run on another core, but it's just stuck there waiting for the single write to complete. And then things are not fun. So use C groups and set up sharing so that you split the CPU usage across from your OSDs and from your compute. That way, everything is segregated. And then, so let's say you are using a certain operating system and you wanted to switch operating systems, because that's one thing that we did. So we originally built our cloud using the Ubuntu Cloud Archives. That's how we started everything. Back when we started, that was the only pretty much packaged way of running OpenStack. So in an OpenStack meetup, that's the cool thing. In an OpenStack meetup a few years ago, David presented RDO, and he was like, this is how we do RDO. This is how we do things. And we got really excited because I was like, so one of the issues with the Cloud Archives is like, it's not an open source thing. Like if there's a problem with the packages, you can only report a bug, and then if they solve it, they solve it. If they don't, well, you got to build your own packages. The RDO way is everything's open source. So if you see a problem with a package, you can go and fix it yourself, and it uses all the same tools that OpenStack uses for contributions, like Garrett and the whole like toolkit. So if you contributed to OpenStack, you can contribute to RDO. And that was one of the big reasons we were like, okay, this is exciting. Now we got to switch operating systems for everything. So we're playing, as you can tell, we're playing musical chairs with everything. Yeah, so this is how we started. Again, I think you're starting to see the pattern. We deploy a few nodes with a different operating system, so the CentOS RDO packages. Now, keep in mind, OpenStack is all Python, so it doesn't really matter if it's running on Ubuntu or running on CentOS. It's just a bunch of Python code. And so the RPC layer will communicate with no problem. So you would just say, hey, let me just run a live migration, and it's the same KVM version on both sides, the same libvirt release on both sides. Everything's going to go well. Well, it's not, because Ubuntu uses AppArmor as their security protection in the kernel, and CentOS uses SELinux. And it turns out that part of the XML file, when you start up a new instance or when it's live migrated, includes the security model that's in use. So you're going to live migrate it, and it's going to say live migration failed, AppArmor not available. And then you're like, oh, shit, this is going to be rough. So turns out a whole bunch of patches later. Oh, sure, question.
If I may add something, it actually makes a difference in what mode SELinux is running between your two nodes. So if you have like one server which is set in permissive,
Yeah?
and another one where SELinux is disabled, you can't live migrate.
Oh, no.
Yeah.
But you should be running enforcing. That's what we all should be doing. No one runs that set enforce 0 before deploying anything. So actually, speaking about that, so in my experience with CentOS, you can run it with SELinux pretty well for compute. For the control plane, there is a few things that will cause a bit of an issue. So you're gonna like set enforce 0 and walk on your way, pretend that you didn't do any of that. So that we had to do a whole bunch of patches to like make sure that the XML comes in with like a different way, because it was just a mess. If it's easier, just shut the VMs down and start them back up with the cold migration and make your life easier, or not. And then finally, I got a lot of questions on the Slack meetup group, which is to migrate a control plane, because we did that a whole bunch of times. And this is where the fun stories come in. It's going to be good. So there's many reasons you want to do that. You want to change the tool that you deployed your cloud with. Let's say you started with Fuel and you want to move to O or something along those lines. Or you just want to replace your hardware. Like you want to replace the hardware that's running a specific service. So most of the services in OpenStack are stateless. All you have to do is just launch a new instance and everything will be okay. The fun part of it is the infrastructure that uses OpenStack. So when we talk about RabbitMQ, when we talk about the Galera cluster, those pretty much are like the biggest, most biggest pains ever. So here's where maybe we talk about fun stories. So we were migrating our Galera DB cluster for a client for our private cloud. And so it's like your typical migration. We deployed a new cluster. We shut a service down. We did a MySQL dump. We took the SQL file and we restored it. That is like the most basic thing you can do. How could that go wrong? So in OpenStack with Neutron, there is no principle of the ordering of ports in a virtual machine. Like the port being the first port or the second port is just like by the luck of chance that they are just in this order inside the database. So turns out that everything was running okay until the customer rebooted their server. And then when they rebooted the server, OpenStack created like a new libvirt XML that had both interfaces reversed because for some reason the MySQL dump like imported data in a different order than it was in the database. So they were like, nothing is working. Our network is not working. We're like, well, everything's working fine. And then they show us like their configs and it's like, we're telling them like, why did you reverse? Did you play with your configuration? These MAC addresses are not, your MAC addresses are flipped over. They're like, nope, we didn't touch anything. And then so that's how we found out that apparently that happened. We don't know how to fix it. We haven't migrated any databases yet. But so I think what happens is like weird, complicated binary things happen and the rollover like starts happening and it's stuff that's beyond me. But you know, you're gonna run into some really fun, interesting things that's gonna happen. So here's one of the other kind of interesting things. You wanna migrate the RabbitMQ cluster. So you need to move everything right away, but at the same time, you don't wanna shut off everything. Like, you can't just say, hey, I'm gonna migrate the compute nodes first, and then I'll do the controllers, because everything will crash. And then you can't do vice versa, because all the compute nodes will just disappear, and then things are not gonna go well. So you try to do your best to orchestrate it by using Ansible, and then right as you do this, you're just that lucky, and a user creates a request for 200 VMs, like just 200 VMs launched right away. So that ended with a really weird, inconsistent state and a lot of fun trying to like get RabbitMQ to understand what it does. And so the other thing that came out of that was, so the way that Neutron works in the DHCP agent is it stores it sends a request to refresh the list of IPs and where they are assigned to the MAC addresses one by one. And so once this person had launched 200 VMs, this agent was flooded with requests just one by one, flushing them. And pretty much that resulted in timeouts and things weren't being launched properly. And it turns out if you restart services, it makes it even worse. Because before, when you restarted a service, the queue would get destroyed and would get recreated. Now there's a timeout that's set up, which is, I think, 15 minutes. So for 15 minutes, there's going to be a consumer that's dead. And then you're going to start again, and there's going to be another consumer that's dead. So you restart 5 or 10 times, you end up with 30,000 messages in your message queue just sitting there waiting for one by one to eventually complete. So that's fun. And then the worst one that we ever had was we had decommissioned a controller node for one of our customers, and it was an on-site deployment. And we were under the premise okay, this person's never going to turn on the server again. Well, they did. And the problem was, so imagine this. You have one OpenStack instance that is running your production database connected to one database, and you have another one listening on the same RabbitMQ cluster connected to another database. And they were pretty much racing. So when you were when Nova was saying, hey, I want a new port, it was either the old cluster was responding or the new cluster was responding. So you ended up with a database that was completely inconsistent because you had a controller that was just doing things on its own. And so that was really fun to figure out because we had no idea what was going on. It's port requests were just being swallowed and were disappearing a third of the time, and a third they would work, and we're okay, well, what's going on? Until we found out what the issue was. So that's no fun. So uninstall services when you're migrating things. Just yum uninstall. You're not going to lose your configs. Everything's going to be there, but just do it for your own sanity, because that was not a fun thing to find out. And I kind of put this up at the end because like everything really works. You think it's working, and then you do the slightest little tweak, and then something breaks like 6 components later that you have never touched before, and you're like, "Whoa, this is related. How did this even work?" So you get to learn a lot. So me doing this since 2011, I've learned a lot, and you kind of get this troubleshooting skill where you're just like, okay, I can see where I have to start going from this. And so I kind of wanted to go fairly quickly. I think I'm pretty good. What time am I supposed to finish? At 20? At 7? Okay, so we got like, yeah. So what I wanted to do, thanks everyone. Thanks for listening for our stories. But what I wanted to do is to ask for people's questions. I know a lot of people have OpenStack deployments, and so I wanted to hear their questions. I'd be more than happy to answer anything that they're having problems with. Sure.
I guess I'm just curious, could you describe the scale of your public cloud? How users and what are they doing?
I can't talk too much about scale. What I can talk about is users. So some of our users, a lot of our users do CI. So what they do, actually, I don't have my laptop up, but we have a lot of customers in the OpenStack Foundation, the Linux Foundation, and they do testing for a lot of these new projects that are coming up. And so they have like a big CI pipeline that runs all their tests on VMs that are deployed and deleted. We also have customers in big data. So that's one of the kind of interesting cases where one of them is an insurance services company. So the next time your insurance goes up because you have a red car, it's probably because it was calculated on our cloud. So they come up with these really cool technologies. So they're the sort of customer that will have no usage for a week, and then they'll be like, "Hey, we're just gonna take up like 700 VMs for a week to do like this big calculation," or I think they call it modeling. Pretty much, we all like to think we're special, but we're not because we're predictable. Computers can predict us, and that's pretty much what they do. So that's some of the use cases for OpenStack and how I've seen users use it. Does anybody else have any other questions or deployment-related questions? Honestly, like.
What version are you currently running?
So we're running Newton right now. To be honest, my word of advice on how I pick which release to run, and this is maybe a bit biased, but when Red Hat says we're released this commercial version, we're pretty much like, okay, these guys are selling this, they have to sell this, they have to make money off of this, they probably tested it enough. And so the RDO packages are pretty much the upstream for the Red Hat OpenStack. So if you want to get a tested version of OpenStack and you don't want to foot the bill, do that. So yeah, so that's my personal way of deciding, okay, which release do we want to go to? Usually go on some good testing. Sure. Honestly, I mean, right? So for me to be like the least biased possible, I always think that like I always think that it's kind of like you got to figure out the balance. I think it's very difficult to do it in-house. Like it will work, but it's not going to run long term. And I think the problem is a lot of people are like, okay, we're going to put 2 engineers, they're going to put up a cloud, and then you want these 2 engineers to get back to do like whatever your business does. And then you're going to realize that like, okay, this needs people to maintain it. And then you find, so we're like working with a pretty large known company that has a 500 node OpenStack cluster that's running Juno. And the reason they haven't upgraded because they're like, well, we're too busy and we don't want to break it. And they have the resources to do it, but they're too scared that something's going to break. And I don't blame them. I mean, as you can tell, things do break. But yeah, so maybe biased opinion, but I think a lot of times it's unless you're running with really big scale, it's probably better to let somebody else run it for you. Anyone has any other questions? I know some people were interested in hearing about deployment methods or what. Yeah, everything is running Ceph. All SSD storage. Joule. We're pretty new on it. We're doing okay on upgrades, but so we're running Joule, we're running RDO OpenStack. It's deployed using Puppet. Yeah. Oh yeah, so a really funny way that we ended up having to implement external monitoring, and not like pingdom external monitoring. Like, there's a company and they're called RunScope. They're not paying me to do this. I like their service. RunScope is an API testing service. So we have like a scripted API test to deploy a new VM and do a ping from that VM out back to RunScope. So they do like webhook tests, and so that pretty much will test like it will test like deploy in a VM, that the VM runs fine, that the networking is set up. That's for external networking, because a lot of times something will go wrong and you have no idea because everything is, the API responds to 100 okay, but you don't know VMs are not really running. So that's a really good way for us to keep up with what's running and what's not. For monitoring, we use a combination of Sensu, client, and Sensu server, and we use PagerDuty. PagerDuty is a system that pretty much hooks into your monitoring system, and so when something goes wrong, it has a full routing system of like who's on call and who it should call and who it should wake up in the morning, and if someone didn't wake up, who should wake up instead, so that they can yell at the other person for not waking up. But that's kind of the monitoring. We do the simple, usual, like, hey, is the server temperatures okay? Is the load averages are okay? Interesting fact, load averages are not a very good indicator of load in compute nodes, especially if you start using things like quotas on VMs, because what they do is they're slowing down that VM, and so load average inherently is how much processes are waiting to be executed. So when you're purposely slowing them down, the load average will obviously get driven up. So I strongly suggest monitoring your idle percent CPU, which to know how much capacity is your server really idle and how much it has more to go. So that's usually like a much more tell sign that something is going wrong, rather than the load averages that are going to be like up through the roof if you're doing a lot of monitoring and things like that. Sure. So we have experimented with TripleO. I think it's a really good tool of deploying OpenStack. Personally, the only reason that we don't use it is because it needs a flat layer 2 network. And at our scale, we don't have that. We have a spine leaf network for our internal network and everything. So in my opinion, if you're like the scale of like 200 to 250, maybe up to 500 nodes, and you're not going to be growing much more than that, I think TripleO is like a really good option to have like a production-ready OpenStack, because there's a lot of testing that's put in it. The architecture is honestly really well put together. As someone who's like used OpenStack for a while, I can tell you it's a really good architecture. We pretty much use it as a reference point to build our clouds. And you are getting the same commercial offering that they sell under the name of Red Hat. Is it OpenStack Director? Yeah. So it's like, it's battle tested stuff. It's stuff that it's being sold. So there's going to be a good amount of support around it. Yeah.
Using the core services, but are you like offering like load balancers, stuff like that? That's around like using a Padia or stuff like that, exporting it to customers, or?
We took that path and started really like investing a lot in it. But one of the problems, and this is more like political OpenStack problems, when the whole like Big Tent thing disappeared. So the idea is any project can be an OpenStack project from now on, regardless of how tested or how well tested or how not well tested it is. So that resulted in a lot of great projects coming, but there was also not a lot of commitments on these projects. And so because of that, a lot of these really cool tools that you're naming don't end up being as like production ready as they are. For example, backup as a service, which is Freezer, which looked great on paper. We tried it out. Everything was going great. Restores fail when you restore from a Swift cluster that uses SSL. So like, that's pretty much like as production as you get. So like, I had fixed that bug after like finding out it was like some weird raised condition, but I was like, I think this should take a bit more testing, especially when you're putting backup software. People rely on this stuff when things go wrong. You don't want this to go wrong when things are going wrong. So that was just one of the examples of doing that. Database as a service has like this weird issue where I think they just lost like the majority of their development team, and then apparently they just kind of gained it back, but there's like some issues regarding multi-tenancy. So apparently database as a service has to share the same message queue. All these agents have to share the same message queue as the controller. And so in a multi-tenant environment, that's just a security nightmare for us. So I don't know how Rackspace does it. I know they run database as a service. From what I understand, it's not really the OpenStack database service so far now. There's kind of remains of it. But we try to stick to the core ones. And again, kind of really silly, but look at the ones that are available in OOO and use those, because those are like tested based on market demand, based on what people wanted, and they're, you know, when they're there, there's like a kind of stamp of approval that's put on by production environments. So I'd suggest that. Anybody else have any questions, or we're good? Sure. So for log retention, we don't see the value in having for like very long-term logs. Usually what we do is we have an Elasticsearch cluster that we send everything to. And typically, you know, not more than a week is enough data for us, because it's very rare that we'll go back an issue that happened a week before and figure out what went wrong. But also, like, don't run verbose and debug, but also run debug and verbose, because the problem is they're really useful when things go wrong. So you want to have them on, but they also take up a lot of space. So my advice is, what we did is we ran a specific filtering driver that allows you to, like, for verbose and like debug things are stored for like 3 days, and then just the general info and everything above that, that's for a week. So that way you're not like throwing away valuable data, but you're also not storing a lot of data, because we generate a lot of log data every single day. So it'd be really impossible for us to maintain like a long-term storage of it. Just wouldn't work for us. Sure.
I don't know if this is too broad a question, but I was wondering if you also do performance investigation on some services, and what are the kind of problems that you usually
So yeah, so that's a very interesting question, right? Because that's when I mentioned like the 200 node thing. That's when we found out like Neutron has this issue where like the DHCP agent cannot keep up with the infrastructure, you know, regardless of how fast it is. It's doing things once at a time. So we've run some really weird issues, and you'll find a lot of really open bugs in OpenStack that include workarounds. So OpenStack still has a lot to come, especially at high scale. So for example, in Neutron, if you're running a node with a lot of ports on it, you know, you need to increase the RPC timeout, because it's going to take a really long time for it to answer, and that's the only way for it to get an answer out of time. Otherwise, it's going to time out, and then it's going to go to a loop forever. So that's kind of one of the things to keep in mind. We also try to be a step ahead of our customers, and usually trying to help them do the right thing. So in OpenStack, when you launch a VM, you can say, I want this number of instances. So you can say, I want 200 instances, and OpenStack will take specific decisions in order to schedule those instances in a much more efficient manner, because it knows you want 200 at once. We had a customer that ran 200 requests, one after the other, for VM after another, after another, after another. So like clearly, it took a bit of toll, because it was like, you know, it was not meant to be, because the scheduler started having race problems, because like all three schedulers that were running were all saying this is the right server to put it in, and then when the server goes to start, it's like, okay, there's not enough space here, because all these machines are like taking the same decision. So those are really weird things that come up. So we try to kind of outdo what our customers could potentially do, but that's kind of always an interesting challenge, because I think we all can agree, like, customers are like the most creative people at breaking everything. If you don't need QA teams, just like leave it in their hands. 30 seconds later, everything's broken. Yeah, I'm not sure if we're good on time, or I'm good. So yeah, if you guys want, we can keep chatting. I have whatever you guys. If you have problems with your OpenStack cloud now, please. I'm not charging anyone for any consulting fees or anything right now. So SDN, right? So we're boring when it comes to that, because SDN terrifies us. So we just do like Open vSwitch, like GRE tunnels, and call it a day, and it works. And if it works, don't break it. But one of the challenges is, so as a public cloud company, we obviously are approached by networking vendors, and they're like, hey, you should change your switches to do this. And so while I think there's a big value, so we're trying to look into bare metal, and there's a huge value in having switches that are aware with the OpenStack network with bare metal, because then you can get on these encapsulated networks on the physical bare metal. You can't do that with, you know, you can't run Open vSwitch on physical hardware. But, you know, the problem is, like, no vendor comes up with a migration plan. They're all like, yeah, here's the solution. Okay, but we got tons of like Open vSwitch all across our infrastructure. We can't really just pull it out and just put something in. we've done that enough times. We've done that enough times, and networking terrifies us. So, that's probably the place where we're not going to be messing around yet. But I do think that it is going to be an issue, especially as you get into large networks. But I'm sure there's people that are way better than me at talking about this in the OpenStack sector. Because for us, it's pretty much just plain tunnels going across, and that works. So if it works, don't mess with it. Yeah. Maybe like a fun Ceph story. Once we had a cluster for a customer, and they were doing maintenance, like at the facility, and so the customer had just started using 220 volt power like plugs because they started like a dense setup. So they're usually like always setting up 110, and we were like, we do high density setup, so we're like, this is not enough, get 220. So they had all, because if you're familiar, the 220 plugs, the plugs are different. They're not like the normal plugs that you plug in here. They're like, if you remember computers way back when you plugged your monitor to your computer, if you remember that cable that was like on one side and on the other kind of like the opposite, you could plug it to itself. That's the 220 volt cables. So they plugged them. So these cables, you got to really push them in and they click in. And so these guys didn't click them in. And they were doing work in the rack, and they had touched some cables. And the problem was, so these were like 4-node, like single unit thing. And so they pretty much like took down, like rebooted like 18 nodes or something like that in the span of a few seconds. And they didn't have battery backup units, and they were running like Ceph with RAID 0 and no battery backup units, and like on SSDs that didn't have battery like protection. So like obviously like everything starts to back up, the cluster is in error state, and nothing is like, it's all gone. Like it's it's dead. So unfortunately, that was not a fun time. They had to restore a lot of their stuff. So if you're going to use RAID behind your Ceph, use battery backup units, and make sure the power doesn't go out, because sometimes it can go out for really silly reasons. And also make sure that your crush fail domains are good. And he's going to talk more about that, I'm sure. Yeah, so there's a lot of like really like horrible things that can happen, and then you just got to look at someone and be like, hey, so you have good backups, right? Because you're going to have to use those today. So that was not a fun time for them, and I don't think it was a fun time for anyone, and hopefully no one has to go through that. So that's why I said, I emphasized the whole get good SSDs. That, they ended up, I think, tossing out over $60,000 worth of SSDs and replaced everything, because we were like, if you don't want this to happen again, you got to get some good SSDs. But anyways, that was a little story I figured I'd throw because there's so much questions. I think that's my time, though. Thank you, everyone, for your time. Thanks for listening. Thank you. You guys got 10 minutes to finish the beers? 10 minutes?